All right. So Stephen, if you are seeing some strange stuff up here, it's just me going through the unit circle. Okay. So not that relevant to you. But now we're going to start working through some questions from unit 4. So the goal for today is I'll give you guys a long list of questions, assuming you guys have the answer. I think you guys should have the answer to all of the questions from the previous sheet, but I'll just send you guys a digital copy of the answers for the textbook.
Oh, by the way, I tried to do I had 3 on that,
Yeah.
and I don't know why, but like I did bad on the simple familiar, but I couldn't the complex unfamiliar.
Oh, you did badly on the simple familiar.
Because on this simple familiar, the first question is about like parameters and statistics, which I knew, but I didn't know.
Okay.
Like
All right.
I didn't practice.
Yeah.
So they asked me that question, and I don't know how to do it, so I lose 3 marks.
Yeah.
But like overall, I got like 70%.
Not bad.
Yeah,
Not bad.
I think it's not bad. Yeah.
Yeah, that's not bad. That's pretty good. Yeah, sometimes the simple familiar could be difficult because it's a concept from the past.
Yeah.
So they think it's simple familiar, but if you don't remember it, you can't do it. Yeah, so that's why at this point is the time where we go through a lot more simple familiar, basic concepts and stuff. All right, let's say this one here. Assume that 45% of people watch more than an hour of Facebook or YouTube videos a week. So whatever, it's just saying that 45% of people. That looks to me. I haven't read anything else, but that looks to me like P, right? The population proportion. Okay. Let's see. Using the normal approximation, determine the approximate probability. This is about normal approximation. Okay. Approximate probability that in a randomly selected samples of size 400, so n equals to, so in the sample here, the sample is n is equals to 400, more than 50% of people have watched more than an hour of Facebook and YouTube, and then find the probability that more than 50%, so the p hat is more than 0.5. All right, so remember, okay, this one is a little bit different. Normally, they wouldn't use the normal approximation. Normally, you would just use the binomial distribution. But this is another concept that when the sample size is large enough, the binomial distribution can be approximated by a normal distribution. And the normal distribution, the normal approximation has these values here. So normal approximation, okay, of the sample. Remember, in the normal distribution, you need mean and standard deviation, right? What do you think mean is?
Mean is a 4 no.
Well, remember, this is the approximation.
45%.
Yes, it is 45%. 0.45, right? The mean is always just the same as the population proportion, right? 0.45. So the idea is that if the population is like 40% people will watch more than that, then if you assume that is the case, then when you take a sample, you also expect the mean of the sample to be 0.45 or 45%, right? But how do we calculate standard deviation? Do you remember, Peter?
Is that just like x? Is that a square root of variance?
Yeah. Square root of variance. What's variance?
Is that e in x squared? Take away e x squared.
Well, yes, but in this case, you can't calculate e of x squared. There's no function, right? Yeah. So this standard deviation is actually linked to is similar to the confidence interval.
What? But they're saying like the normal approximation. How's that?
Yeah. Confidence interval is linked to the idea of normal distribution. Remember, confidence interval is the idea that when you find a 95%, right? Yeah, so it's similar. What's the formula for confidence interval? It looks something like this.
P hat.
Yeah. So the confidence interval, remember I told you guys that it's the p hat and then plus minus. So the interval is basically p hat and then plus minus what? Z times sigma. You see, this the reason why I said this is sigma is because it's very similar to the sigma for the normal approximation for sample proportion. Right? It's the only difference is that this sigma, right, is square root of p hat because we don't know the population proportion, so we have to estimate it using p hat. Right? P hat 1 minus p hat and then over n. Now note that the actual normal approximation, the because we are assuming we know the sample proportion is p times 1 minus p over n. Right? But it's still the same thing. Instead of using p hat, you use p. Okay? So in this case, you would write, you can write like x is approximately normal. Actually, you can write mean is equals to 0.45, and then standard deviation is square root of 0.45 times by 0.55 over sample size, which is 400. Okay, so that would give you the standard deviation, and then when you calculate the probability here, you just need to use the so then PR of p hat more than 0.5. This is just the normal distribution, right? And CD, and then lower would be 0.5. Upper would be, you can just go 999, and then mean is 0.45. Standard deviation, let's quickly calculate that now. Okay, so standard deviation is 0.02487. So yeah, put 0.02487. Okay, then you should be able to get the answer. Normal and CD, lower 0.5, 999, 45, 0.02487. Okay, so the answer to this, the probability is 0.14. Okay, what's the I think they assume to be 2 decimal places, I think, or 4 decimal places, can't remember, depending on the exam, but let's say 4 decimal places, 0.1455, so that's 14.55% chance. Okay, yeah, that's about it. So the only thing that's somewhat new is this normal approximation for the sample proportion here. This is the chapter, I think 18C, that I didn't really go through because the formulas are quite similar. So I went through the confidence interval ones first. But this is the last thing that you guys need to know for chapter 18. Okay, all right. Any more questions, Peter?
No.
No? Okay, so now the plan for today's lesson is I will give you guys a really long list of questions, and I will give you guys some hints. If it's too hard, I might go through a few parts of it, but if not, then just you guys just have to work through it at home and then check your answer and let me know if you have any questions. All right, the first one would be, let me get my list up.
Oh, how's the JBC test?
JBC test?
Yeah.
They said that I asked them and they said that they did okay, but there was one question about optimization that was a little bit difficult. So I actually do remember the question. So the question is this: given a graph that looks something like this, and the graph is y equals to b over x. Okay, and then they choose a point P on the graph. Okay, and then they draw a triangle OPQ. Okay, find the minimum distance of OP. That's it.
OP.
Yep. Find the minimum distance of OP. So actually we can try going through this one here. This is a very tricky optimization one. Like that's it. They don't give you anything else. They give you the equation of the graph and then this main concept here. So how do we find the minimum distance of OP? Any idea?
I think first we need to get like an equation of like what is like OP first.
Yep. So how do you think we get this equation?
I think we.
What's the idea?
X. But what is B then? I don't know B.
B is just any value. We don't know what B is. The answer will have to be in terms of B.
Alright. That's tough, eh?
Yep, I know. the idea here is that you need to start with what you know. What kind of triangle is this? OPQ.
Is a right triangle.
A right triangle, right? Okay, so right triangle, which means that OP squared would be OQ squared plus.
I was thinking of that one, but I don't know how to demonstrate the equation with that.
Yeah, just use the points, right? OP squared equals to OQ squared plus PQ squared. All right. Now, can we write? Now, the idea is that when you get a question like this, right, you need to see what happens when you change a value. So, for example, I would choose a different point P and see what happens here. Okay, so this is technically a different triangle. So this new P dash, right, is longer. OP dash is longer than OP, right? But that's because remember the point P is that has to be on this line here. So how do we link the equation of the line into this equation here? If you can figure this out, then the rest of the question will be easy. When in doubt, you just have to pick a value, right? You have to pick a set of value, let something be a value, and then see what you can do with it. So for example, leaving the P dash there, let's say if I let OQ, right? Because remember, this is an equation. An equation has an X and Y coordinate, right? So for the point P, there will be some sort of XP and YP, right?
Yeah.
Now look at the point XP and YP. Can I replace anything in this equation with XP, YP?
Yeah.
Yeah, what can I replace?
You can replace the OQ to XP.
Yep, okay, so let's try that. XP squared, yep.
Plus BQ, oh no, I mean YP.
Yep, plus YP everything squared. Okay, so this is the new equation for OP squared. Yeah. Right, we're getting somewhere. How can we use this equation here though? What's the relationship between XP and YP? Because if you can just find one of them in terms of the other.
Coordinates.
Yeah, coordinates, yes. So let's say YP, right? How can you write YP in terms of XP?
YP.
Remember, the point P is on this equation, is on this line. It's on the line, so
I think it's like,
Y must be.
So YP is equal to B over XP.
Yes, it is B over XP. That's right. So you see, we can solve it, right? Because if you want to find the minimum distance of OP, we've got the equation of OP in terms of X, in terms of the XP, right? Yeah, so the distance of OP must be dependent on this specific equation here. So now we can derive it and then solve yada yada. Now it's easy. Okay, so if you go once again to make it a bit easier, XP equals A. Then we've got OP squared equals to A squared plus B over A, so that B squared over A squared basically. Okay, but note that the X, like this A value there, is a variable, right? This is the one that's changing. B is a constant. Okay, so now we need to derive OP with respect to A, right? Because A is the variable that's changing. Yeah, because the X of the this is XP, right? This is XP dash, and the point Q is actually just XP, right? So we're deriving with respect to XP. So actually, maybe it might be easier if we just leave it this way. Let's see. So OP squared equals to XP squared plus B squared over XP squared. So we need to differentiate OP with respect to the coordinate, the X coordinate of P, because that's the one that's changing. So then that would be 2XP, and then this one would be B squared, and then XP to the power minus 2. So that's minus 2 of B squared over XP to the power 3. Okay? Yeah. And then we're trying to find the minimum value. So we set that equals to 0. So 0 equals to that. Okay? And then we shift this term to the other side. So that would be 2b squared over xp cubed equals to 2xp. Okay? And then
Yep.
And then the rest is easy, right? Just times that one over. So 2b squared, divide both sides by 2. So b squared is just xp power 4. So then when you root 4 of b cubed, it's just, if you want to solve it using index law, it would just be like something like this. Okay? And then 2 times 1 over 4 is 1 over 2. So basically the answer is square root b equals xp. Okay? So that's, sorry, give me a second. Alright, so the xp is square root b, but we still don't know what's the minimum distance yet. So now we need to sub this into sub xp equals to square root b into
y.
Yeah, y or op, the equation for op. Okay, so now we've got this thing here, op squared equals to basically that thing there, right? Yeah, so then we've got op squared is equals to xp squared, which is square root b, so that would be b. Yeah, and then plus b squared over
1 over b.
B squared over b. Yeah, so op squared would just be 2b, and so op, since op must be positive, it will be square root 2b. That's the final answer. Okay, it's tricky because they give you they give them only a variable b.
So I did this kind of question before, and the problem with this one is like to figuring out the op.
Yeah.
For 2.
It's always the first equation. Once you've got it, the rest of it is easy. So the complex unfamiliar questions is only hard at the beginning, most of them. Right? Once you get the beginning right, I think you should be able to do the rest of it.
Yeah.
Okay? So this is the hardest one that they got on their tech-free, on their non-tech calculator. It's the very last question. On the tech-free, it was so hard that they remembered exactly what the question was. Yeah. They just told me exactly what the question was. Like, oh, okay, I can see why you couldn't do it. And they also had angle between planes. Remember the common line techniques? Yeah. So they actually had a question like that, and they could all do it because they were like, oh yeah, easy, went through that with code. But that was a little unfortunate because normally you don't get that angle between planes question that often. Normally in the external, they would ask you that. Internal, that's a bit mean to ask angle between planes. Most students would struggle so hard to find the angle between planes because most teachers don't even teach that at school. But anyway, so yeah, they actually did okay. Could have been a bit better, but yeah, it's okay. They're happy enough with the results now. It's just externals now for them, for revision.
That's good.
Yeah, it's okay. We've got 12 weeks, so that's enough time. If you guys don't slack off, you guys will be fine. All right, so the first one is this question here. Okay, question 4. Actually, I'll write down what chapter and what question this is, so you won't have to go and try to search for it. So first is chapter 12a. Okay, and in this question 4 here, find f, the second derivative, and then substitute 0 in. Alright, I'm not going to go through this question, but you guys should try this one. This is a simple familiar one. The reason why you should try this is because it has the e to the power something. Remember, when you differentiate e to the power something, it stays the same, but you got to differentiate the power and times it down. Okay? Yeah? And then this one will just be power 1/2. And same thing, it will be a chain rule. And same with this one here, cos of x squared. So cos becomes negative sign, but then you have to times it by 2x. Yeah, so with negative sign of, I'll just show you the first derivative for each of these maybe. So this one would be cos is negative sign of the same thing, but you differentiate what's inside it, which is 2x. And you have to differentiate again. But note that when you differentiate again, this would be product rule. See that, Peter?
Yeah.
Yeah, so be very careful after the chain rule in the second derivative, even though it's a simple familiar question, right? Because if it's a chain rule, you will always have another factor multiply into it. So the next derivative will be a product rule. Okay, similar to this one here. So f dash, since this one would be power 1/2, right? That would be 1/2 1 minus x squared to the power negative half, and then you have to differentiate what's inside, which is negative 2x, right? Even if you simplify it, it will still turn into either a product rule or quotient rule, up to you. Because if you convert this one into, let's say, negative 2 and 1 half cancelled out, so it'll just be negative x over square root 1 minus x squared. This is the quotient rule when you do the second derivative. Right, so this will be the quotient rule. Yeah, so that's why it's a little bit tricky, and then you gotta derive it twice before you can substitute 0 into the value to solve for it. Okay, so these questions are not that hard, but be very careful. You need to get these ones right. Any questions, Peter?
No.
No? Okay, go back, practice that. Next is question 5C. Well, question 5 in general. So this one is about, still the same chapter here. Yeah, okay. This one's a little bit different. Before, it was finding f double dash at 0. This one is solve for f double dash equals to 0. What are we solving for here? This is to find what?
Find the nature?
No.
Point of inflection?
Yes, to find the point of inflection. Okay, so when you set second derivative equals to 0, you're finding point of inflection. They're not asking you to find point of inflection, but in the exam, I'm pretty sure they will ask you to find point of inflection, and you're supposed to know that. You set the second derivative equals to 0.
Check the nature, you solve the x values into f second derivative, right?
Into second derivative, yes.
Cool.
Okay, there will be some nature questions a bit later. So yeah, when you solve it, note that when you work through this one here, when you derive it once, it will be x power 3, right? Something something, and derive it twice, it will be x squared, something something x squared. So you will have to solve a quadratic equation for question C. Okay, so f double dash would be something something there, which means when you solve this, it will be a quadratics. Solving quadratics. Alright, so make sure you get at least question 5C done if you think the other ones are easy. But you should practice. The other ones shouldn't be too hard. If you're comfortable, you can do these two questions, because when you derive it twice, it's linear. Right? You can solve it like even in your head once you've got the second derivative. So it shouldn't take too long. Next would be question 6. Now, this one is simple familiar, but it's one of the harder ones in terms of simple familiar questions, because you need to remember product rule, chain rule, and a bunch of factorization. So the idea behind this question, again, I won't go through this. This question is just for practice. So product or quotient rule, all right? Product or quotient rule, and then you need to factorize to solve for it. So factorize, and then no factor law. All right? Most of the time, when you're solving something equals to 0, is no factor law, right? Most of the time, but you need to be able to factorize it by taking out common factors and stuff. Okay, so that's question 6, and then that's it. So next would be 12B. Okay, so the first question I want you guys to practice on 12B is question 1 here. This really tests your understanding of the second derivative. And I know I went through this like two times before already. This is the third time I'm getting you guys to do this question. Okay, but this one really tests your understanding of the second derivative. I don't know why it's the first question in simple familiar, but you know, we just got to do it. So this is chapter 12B now. And again, I'll send the answer sheet, the digital version of the answer sheet, so you can just check your answer. But make sure you do this one. All right. Remember, you need to interpret what it means by this and then what it means by that. Right. Let's try. Peter, what does it mean by the first one here?
It's when it's concave.
No, it's already wrong. That's the first derivative. It has nothing to do with concavity. Alright, when the first derivative is more than 0, what's the idea behind the first derivative? What's the concept behind first derivative? What does it give you?
Is that increasing or?
No, it gives you the gradient. So, well, technically, yes, you said if you had said whether the graph is increasing or decreasing, then yes, you're correct. Yeah. Right? But in this case, it gives you the gradient. So gradient is positive. Okay, that's what it means, right? Gradient positive means it looks something like that. Yeah, and then the second one here, what does that mean?
Concavity.
Yeah, so this is concave. Up or down?
Concave down. Concave up.
Up or down?
Concave. It's positive, then it's gonna be concave up, and it's gonna be the local minimum.
Yes, concave up. Good. Yeah, I'm just making sure that you're not questioning your own knowledge. Okay, it is concaving up. So at this point here, concaving up. How do we draw concaving up? Well, it's something like that. Okay, make sense? Yeah. So that's the answer of question A. You gotta see if you can sketch B, C, and D correctly.
Yeah.
That really tests your understanding of the concavity, the difference between the gradient and concavity, or the first derivative and the second derivative. So that's question 1. All right. Next would be this one here. This one, a very standard questions, but I don't know why. Whenever I go back to this one, people struggle. Might be because of the inequalities. I don't know. But when you are solving for everyone can do points of inflection. Okay, everyone can do this one. But when asked where the curve is concave up, people have no idea. Okay, so note that. Okay, I'm going to show one example. So question A here. Yeah, actually I'll show question C. X squared minus x cubed. Okay, so this that's the original equation. This first derivative would be 2x minus 3x squared, and then the second derivative will be 2 minus 6x. Okay, so point of inflection means 0 equals to 2 minus 6x, and so for x, so 6x over here equals to 2, x equals to 1/3. All right, so how do we find where the curve is concaving up?
Just sub that into.
Is it gonna be this, or is it gonna be this?
We're gonna check the nature.
This is the second derivative, so the nature is that it is the point of inflection. Now, the question is it this kind of point of inflection, or is it this kind of point of inflection? Which version is it? The red or the blue one? How do we know?
We sub in the first derivative.
No.
No?
See, most students can't answer this question. I don't know why. Well, I guess I do know why, but that's why I'm going through this one. You need to test a point before or a point after, either way.
Yeah, that's what I meant.
But you don't sub into the first derivative. You sub into the second derivative. Okay? Because the first derivative doesn't really tell you much. I mean, positive, negative. Yeah, it might work, but I prefer to sub into the second derivative because, for example, if I choose a point before, right? So a point before would be 0.
Yeah.
Alright, so x equals to 0, for example. Then f double dash at 0 would be 2 minus 0, which is positive. Right? Which means that, so what does that mean here? It means at x equals to 0 is concaving up. Right? So it's concaving up before, which means it has to concave down after. Right? Which means that it is the answer is going to be the red version here. So how do we make the final answer here?
Final answer?
Yep, that's not the final answer. They ask where the curve is concave up. And so here you would write f double dash at 0 equals to 2 minus 0, which is 2. Therefore, concave up when?
Concave up when x is bigger or equal to 2.
And that would be wrong.
Wait, x. When
You see?
x.
Okay, can you do this one? Simple familiar.
When, so from 1 over 3. So 1 over 3 bigger than x. I mean smaller than x and smaller than 2.
That's wrong. Where's the 2 coming from?
Oh, then 0.
Where's
So
the 0
zero,
coming from? Why are you stopping the graph at 0?
Oh yeah, so when x is smaller than 1 over 3.
Yes, when x is smaller than 1 over 3.
Oh my god.
Does that make sense?
Yeah.
Yeah, it links a lot of concepts in. That's why this question is one of those things that it's supposed to be simple, but most students won't be able to do this.
Practice this stuff.
Yeah, this kind of question is the one that would come out as a simple formula, and you'll be like, what the hell? I can't do this one. Okay, so another way to visualize this is this. So at x equals to 1/3 is the point of inflection, right? But then given that f double dash of 0, so concave up. So let's say 0 is here. Okay, so x equals to 0, right, is concave up, right? Which means that at this point here, it's like concaving up. If I draw it concave up here, it doesn't make sense because I cannot cross through that one here, right? Technically you can, and then it will concave down after. Yeah, it should work. Yeah. So it doesn't matter what you draw it, as long as you draw at x equals to 0 is concaving up, and then it changes in concavity at the point of inflection, so concaving down after. Yeah. So note that. So that's why basically what we found, the value 2 is to show that it's concaving up. Yeah. But the region that it concaves up only links to the number 1/3. Okay. So make sure you go practice these ones. Yeah, see, I knew it. Simple familiar, but most people won't be able to do this one. Okay, let's see. What was another one here? Point of inflection. Similarly, you got to do this one here. These inequality questions are not easy, but very possible in the exam. Okay, it's the same thing. You need to, if you're solving for an inequality, you need to solve when it's equals to 0, right? And then you need to find the regions where it's less than 0 after that, by finding a value before and after and all that stuff. Okay? Or negative gradient. Yeah, let's go to try out this one. I won't go through this yet, unless you guys have issues with these questions. Okay, let's see. This one. Sketching a cubic or quadratic equation is very standard for Unit 4 exam, because you guys have learned the second derivative, so this question should not be too hard. Okay, so you just gotta find a stationary point, set derivative equals to 0, and point of inflection, set the second derivative equals to 0. But remember, you always need to find the y coordinate. Yeah, find the y coordinate so you can put the point onto the graph. No, any question? No? Okay. Yeah, so go back and try these ones. So that's the end of 12B. So second derivative in graph sketching. I think the other ones could be a bit not necessary for now. All right, next would be absolute max and absolute minimum. The first one I want you guys to try is question 3 here. Peter, what are the steps to find absolute max and absolute minimum?
Absolute maximum is when it's just like local minimum and
no,
maximum.
Not exactly just local minimum and local maximum. There's something else.
You mean like how am I gonna find it, or what does that mean?
There are only 2 steps to find absolute max and absolute min.
When the f, the second derivative is equal to 0.
No.
First derivative.
No. Absolute maximum and absolute minimum links to y values.
Yeah.
So both of these steps start with find the y values of what though?
Y values.
They're both finding y values of 2 different kinds of points.
Is that the domain.
Yes, the domain. Very good. Find the y values of the start and end points. Right? Start and...
Ah, I remember, yeah.
Okay, remember this?
Yeah.
Absolute max, absolute min, and then the other one is find y values of...
Local max and local min.
Yes, or stationary points. Okay, or local max and local min. That's it. These are the only two steps you gotta do. And what are and the highest value will be the highest, that will be the absolute maximum, and the lowest value is the absolute minimum. That's it. Yeah. Okay, so that's question 3. Next is question, let's see, I think I put down here. No, I think I'll pick something a little bit different. Try this one. So again, I'm not going to show you guys the answer for this one. I'll just give you some hints. Okay, so when you see show that, what do you do? Yeah, when you see show that, what do you do?
You skip A.
Skip A, yes. Alright, skip this one first. Then you derive this. When you see an equation like A here, what's the first thing that comes to your mind when you derive it?
I gonna times it in.
Times 1 over 8?
Yeah.
Is
Or I can. Oh no.
You do the opposite of that. You leave this thing alone. Okay, leave this alone.
Alright.
Okay, because example, right? If you have like 1 over 200 times into an equation like x squared plus 2x, all right? When you find the first derivative, d over dx, okay, I'll write it as d over dx. If you times it in, you have to times 1 over 200, and then you have to times 2 in, simplify, yada yada, and then you factorize again. If you leave it by itself, it just becomes 2x plus 2. That's it, right? If it's a constant factor, when you derive it, it doesn't change anything, right? So you can derive what's inside the brackets before you multiply in the constant factor, and then it will make things a lot easier. Okay, because if you times the 1 over 8 into this equation here, it's going to make it like, this one would be like 10 over 8, and then you have to simplify, and later on you have to factorize it out again.
Alright.
Okay, so that's why you leave it alone when you see a constant factor. You leave it alone when you antiderive and when you derive.
Yeah.
Okay, find the value of x that makes a minimum. What are we doing here? Question C.
Make a minimum. So you're gonna find the for when d over dx is equal to 0.
Yep.
And then you're gonna get 2 values or maybe a 1.
Mm-hmm.
And you're gonna check the nature of that using the second derivative.
Yep.
Determine which one is the minimum.
Mm-hmm. Yeah, that's it. Right. How about this one here? That's what's the idea behind the last question here?
2 squares.
What's the idea behind this one?
So the one piece of the string should be.
No. The keyword I'm looking for is, this is a absolute max, absolute min problem. Right? Maximum possible area, so this is an absolute max problem, and we already know what to do. Right? You gotta sub these values into the original equation. Right? And then you need to note that if x is between 0 and 1, if the local max, right, that makes a combined area, maximum possible combined area. Okay, So if the local max is greater than 1, then yeah, this isn't single. Okay, yeah. If local max is greater than 1, then absolute max, right? Then absolute max would just be a at x equals to 1. Does it make sense? Yeah, because what I'm saying is this: if this is an equation, right? Oh, I think actually this will be this equation here. 0. Yeah, it will be some sort of an equation like that. So yeah, no. Oh, actually, you know what? I'm not gonna explain this one. You guys go back and do it.
Alright.
Figure this one out for yourself. Question D is not easy, but it is a very good example of these kinds of like absolute max, absolute min question. You gotta be able to reason it out and figure it out for yourself. So I'll just give you guys a hint here. Is you need to do this one, you will need to draw or sketch. And you can sketch it. What kind of equation is this? What shape of the equation? What shape is this equation?
Quadratic.
Yeah. So this is just a parabola. You can sketch it. Okay?
I can't remember how to sketch it. I can't remember how to sketch a parabola.
Parabola, it's either this or that, right? It's one or the other. And so if you can find the value of x that makes a minimum, that's basically the local minimum, right? And then find out where that x value is. You can find where the local minimum is. And is this going to be concave up or concave down?
I think it's gonna concave down
Why?
because there's negative in it. Oh wait, no.
Right? Concave up or down and why? You can't answer this, you're not ready for externals. It's concave up.
Concave up because when you sub 0 in,
No, it's positive x squared.
yeah.
If it's negative x squared, then it is concaving down for quadratics. Okay? Because this is concaving up, you can sketch it. There are only a few versions. Okay? So either you have above the x-axis, or you have okay, I'll just show a few versions. So either above it, 2 intersections, or one x-intercepts, right? 2 x-intercept, 1 x-intercept, or no x-intercept. One of these 3 versions, right? And technically, if you find the local minimum point, you can just sketch it. If you find the local minimum and you find the y-intercept, say x equals to 0, you can find it. You can sketch it. Okay?
So you have to sketch.
You have to sketch it, otherwise you can't reason this one out.
Alright.
Right? You have to practice sketching quadratics.
Yeah.
So I'm not going to go through this one. You're going to go back and practice.
Do we have to do this kind of math in university?
Depends on what you're doing, but most likely for
Is
you, no.
Is it
If you're doing software, you don't have to do this.
Is that part of calculus?
In there, I think there will be some math courses that you have to do if you're in engineering, and you will have to do some of these again, the derivative and stuff, differential equation. So actually, it's the stuff that Steven is doing at the moment, specialist math. And you have to do that for 2 courses in if it's UQ engineering. I think most other engineering you also need to learn a little bit of it just so they know that you can actually do those differential equations and stuff. It's not hard, but yeah, it's quite similar to these things anyway. But you don't need to do it to this extent, I think. I can't remember exactly, it was too long ago. So I wonder it will be different now. Okay, so 12C, that was... This is the last one I want you guys to try out for 12C. I think we might need to go a little bit faster. I need to cover 12 and 13. Alright, so this is the one, absolute maximum, absolute minimum value. Same thing, I'm not going to cover it again. Okay? So after this would be 12D. So this is the chapter with all of the optimization questions here. Alright, optimization problems. The first one would be question 4. What was it? 4 and 5. These are simple familiar. Shouldn't be too hard. Alright. I'll give you guys a hint for question 5. So for question 5, they have an equation like p cubed q equals 9 and z is 16p plus 3q. You need to find q in terms of p to get rid of the q here. Okay, so sub q in terms of some sort of a function of p. So you need to find what this relationship is. Alright, and then you sub in, and then you can go d. So make z a minimum means you're just finding p and q where dz over, let's say if you sub p in terms of q, then dz over dp is equal to 0. Okay, so this is the optimization one. So this one you just have to sketch it, draw and sketch for question 4. Yeah, that's it. Just gotta go back and try these ones. Next is question, this is a very 12D. Yeah, try this one here. Again, it is just applications of what I showed you guys earlier of absolute maximum, absolute minimum, and see if you can do it. Okay, because the thing is, if I give you guys too many hints, you don't have the time, like the chance to practice problem solving. Now this one is a real problem solving one. You gotta solve for this one here. Okay. Double check, but I think this one must be that's the maximum profit per article. I think this one might be tag free, but check with the let me check with the answer first. So try this on tag free. So just make a note here. Try tag free. The numbers look like a tag free kind of question. I think. Hang on. And maximum daily profit and maximum daily profits and sketch a graph of P against N. Yeah. Yeah, try tag free.
Yeah.
What's the shape of this graph?
Concave down.
Concave down parabola, yes. Okay, alright, go back and try it. Alright, that's it. Next would be chapter 13. So now we're moving on to the trigonometry chapters. How many questions have we got so far? 3, 4, 5, 6, 7, 8, roughly 9, 10. 13, roughly 13 questions. So the list has about 13 questions so far. Yeah, plenty of time, things for you guys to do, but still not everything. So moving on, we've got chapter 13a. Yeah, so there's only one question I want you guys to try out from chapter 13a, which is like an easier type question for trigonometry, which is question 7. Yeah, so this is tag active, and it's a pretty easy one. Actually, no. I think for you guys, I would recommend question 8. Advice, sketch. You should be able to do it. Okay, and then next would be 13b. Okay, so 13b, remember the sine rule has this special version where there are 2 possible angles. Yeah, and the question I want you guys to try out will cover this, which is 2 sides. Is this one here?
Okay, cool. Can we solve one question in that?
One of that?
Yeah.
Sure. So this is 13b, and note that this one will have two possible triangles. Yeah. Okay. Now let's see. I'll show you guys question A. We've got side B 17.6, side C 15.3, and then the angle C, which is the angle opposite of side C. So remember, the Okay, let's see. So if you were to draw, just a quick note, A, B, and C. Then this is side B, this is side C. Included angle is A, and then the non-included angle is C, which means, okay, so I'll quickly map this one out. It means that the two sides that are fixed must be this one here and the angle here. Right? So this side B and the angle is fixed, that you can't change it.
Yeah.
So if I were to draw it, I would change it a little bit so that the angle C is on top. Right, and then the side B is the fixed one here.
Yeah.
Yeah? Oh, hang on. Yeah, B here and then C. Oh, sorry. I'll draw the sides, the angle here, because remember the triangle is normally like that and then it's like that. Yeah? So I draw the fixed angle here first. So that's angle C is here, and then the side B, which is fixed, so that will be 17.6. So B equals 17.6. So that's how I like to draw it. Okay, I like to draw it based similar to the shape that I learned, which is the angle that is fixed on the left hand side. All right, and now the other side, the one that is movable, is side C, and this angle, well, I'll put this one in first, 48.25, and then side C is 15.3. All right, so 15.3, there are two versions. It's either this 15.3 or this 15.3. Okay, so I'll have to write this on is C, and this this is side B, so this is B, and this is B dash, and this is going to be A. Okay. Yeah, so then you can just apply the sine rule first. So using the big triangle here, the angle B. All right, so sine of the basic angle B over 17.6 is equals to sine of 48.25 degrees over 15.3. Okay, and then you gotta solve for B. So solving for B, I'll just quickly work that out. It's going to be inverse sine of 17.6 times sine 48.25 over 15.3, which is 59.1162 degrees. Okay, so that's the angle B. Now the angle B dash. Okay, so this is the angle B, and the angle B dash is just what? How do we find angle B dash?
B dash is 180 take away B.
Very good. Is 180 take away angle B. Okay, so that would just be 120.8838 degrees. So I'll write the final answer in whatever decimal place they want, but I'll just use 4 decimal places first.
Yep.
Okay, so 120.8838 degrees. So now we've got the two angles B. All right. Now, what would the side, the missing side, be then? How do we find the missing side?
B, we use sine.
Sine rule, yeah. Use sine rule again, right? And yeah, just use the sine rule again. So there will be two sets of answers, right? So you need to find like CB dash and then CB.
Oh, do we need to say, for the final answer, do we need to say that, for CB is this and CB dash is this? Because
yeah,
there are two solutions, right?
Yeah, there are two solutions, yeah. Let me just double check what the textbook recommends as the answer. I think they just say or something. Let me see. This is what? 12B, question 4. 13B. Yeah, or. They just say or.
So only the length, not the angle.
No, both the length and the angle.
So
because the angle, there are two values for angle A. It's either this one or it could be the big one. Right? So there are two different values for angle A. So there are two possible triangles in this question here.
Yeah.
Yeah. So go back and do this one. So that's the one that I want you guys to do for 13B. And then next is 13C. 13C is the cosine rule. Actually, our cosine rule is pretty simple. I'll skip that one. You guys can just like do.
Yeah, I'm okay with that.
Yeah. Area, same thing. We'll go to the bearings and stuff first. So the bearings and the so we'll go through the bearings and the 3D stuff. Okay. So 13D is, I know we tried these two before, but you should try these two again. Okay. is these questions that are very similar to what you would potentially get in the exam as bearing. So that's 13E. Okay, just remember keyword starts from L, due east, and then cells 9K bearing of something 2K. So bearing of 142, if it's implied, if it's it, then it means that this is from where?
Then cells bearing of
Yeah, so 142 degree from what point?
from L.
From L?
From M.
From M, yes. So this is implied that it is from M. Okay, so then you can draw the north line and yada yada.
Yeah.
Okay. Yep, that's it for 13E. Try out these harder ones, and then 13F are the 3-dimension ones. Like all of these ones are all good questions. Maybe just try something that we haven't tried before. This one has a bit of this one has a bit of bearing in it. Okay, so see if you can sketch it, because I'm assuming if you can actually sketch, if you can sketch it, you should be able to do it. Sorry, let me just quickly. Is these 3 questions here? I know that normally I say in the last week of exam you shouldn't do too many difficult questions, but I'm picking complex familiar because I think you can do it. Okay, and Stephen, definitely you have to do these questions. Okay, so this one is the 13F. Yeah, this is 13F. Okay, all right, try these ones. So make sure you sketch it. Very important, sketch it. And remember, at some point you might need to draw a simplified diagram. Okay, draw simplified diagram. So at this point, I'm just gonna tell you guys what the techniques that I recommend are. You're just gonna go back and try. Okay, so make sure you sketch it, and if it's too complicated, draw a simplified diagram. That's it. Now, angles between planes, 13G. I think just try the first 2. I know these are a little bit difficult, so just try the first 2 as like a revision on this angle between plane stuff. The other questions, I think it's too hard to be of use right now. If you get them, good luck. Not much I can help you with if you get one of these ones. It's got to practice the easy ones and hope that when you see a harder one, you will be able to figure some of it out. This is 13G. Okay, I'm not going to go through these. We've gone through them before. Okay. If you need help, just let me know again. But the technique is common line technique. Okay, so common line technique. Okay, that's about it. Okay, so that's 13. That's it for chapter 13. Alright, I'll stop the first recording here because in the second half I'll start going through what questions you should be doing for the statistics part of it, which is actually quite big. It's going to be from chapter 15, 16, 17 and 18. Yeah.